before, but I just want to make sure that everybody has all the dates in their planner or in your phone, wherever you need it, because the EOC is coming up really soon. And you guys already know that for those tests, for EOC and FSA tests, everybody who's MSO has to come in to school for those. So just be aware that at the end of May, you're going to have your algebra EOC and you'll have to come in for school. So we're in April right now. That's April 12th. We're right here. And we're starting topic 10 today. Like I mentioned this before, it's a pretty short topic. So we'll be done with it by next Thursday. And then on Friday, you guys are going to take, instead of taking a full topic test, it's just going to be one day. And it's going to be, I'm still going to call it a test, but the reason I'm saying it's a quiz is because it's much shorter. So, but it'll only be one day. I'll probably have about 15 questions. It'll be on Microsoft Teams, and you'll start it and finish it all on that same day. Then after that test, we will start reviewing for the EOC, and we're going to review for the EOC for about 1 month, for 4 weeks. It'll be a lot of information. It's going to be very important that while we do that big review, anybody who hasn't been up to this point keeping up with taking notes or keeping up with their homework or things like that, that's the last month. That's your last chance. That's it. After that point, it's the EOC. So I need everybody to just be aware that starting the last week of April, in a couple of weeks, it's crunch time. It's the last chance to do better than you've been doing in the past, if you're somebody who hasn't been doing well in the past. I have plenty of students who are doing just fine. Y'all do not need to stress if you are already having a good average. So I'm talking mostly to the students who are currently in the yellow or the red. Okay. Now the EOC is May 26th and 27th. 26th and 27th. So please make sure that that date is written down somewhere. Put it in your phone, put it in your notebook, write it on a sticky note, text it to your parents. Just make sure that you and your guardians are aware, because they have to drive you, or you have to find a way for somebody to take you to school that day. So take a moment right now. I'm going to let you take a moment to write that date down, and so you have it. Somebody in the chat was asking me about the writing FSA. I shared that with you the other day, but let me pull it up so that I can show it to you guys one more time. Give me 1 second. So algebra EOC is probably going to be the last test that you guys take. That'll be the last one. Writing FSA is probably the first one, and that's going to be, for most of you, that's this week. So if you don't have that date already, I shared it with you last week. Here it is again. The first batch of students, Christopher and Naomi, you guys are going to be taking it on Wednesday. So it's very important that you guys have that date written down. A few of you, Raymond, Allison, you guys are taking it on Thursday. So be aware, you have to be in school. Okay, so make sure that these dates are written down. I'm scrolling down a little bit so my 8th graders can see their names as well. Does anyone have any questions about the writing FSA? That's all this week and next week for a few of you. Do we bring a computer? No, you do not have to bring anything except for yourself. Okay, however, here's my one caveat to that. If you cannot get picked up right after the test, okay? So first of all, you need to try to get picked up after the test. If it's possible, if your parents or somebody, cousins, aunts, somebody can pick you up, please make sure that you get picked up right after the test. If you can't get picked up right after the test, let me know. I'll make sure it'll be okay. We'll find somewhere for you to go. But if that's the case, if you cannot get picked up right after the test, then yes, bring your laptop. That way you can go to your classes afterwards. Do you go directly to that room? I believe what's going to happen is you're going to get to school and then somebody is checking people in at the door, and then they'll tell you where to go. So just have that room number written down so you know where you're supposed to go. But when you get to school, they might send you somewhere else first. Like they might say, okay, go to the auditorium for now, and then you'll have to go to your room. You can walk, David. You can walk. But David, you can't walk home. They're not just going to let you leave. Okay, so I believe you have to get picked up by somebody. Or you might need like a note. Just ask, you're in school, David, so ask somebody at school because they might have a better answer than me. Do I bring my book bag? Yes. And if you're a physical student, then just it's a normal day of school. So bring your backpack, bring what you usually bring. I'm talking mostly to the MSO students right now. So if you're an MSO student, just bring yourself. You don't even need to bring a pencil. They're going to give you everything you need. And then make sure that you're wearing a uniform if possible. If it's not possible for you to wear your school uniform, let me know. And make sure that you arrive before your start time. So don't be there right at 9 o'clock, be there at 8:40. Don't be there right at 11, be there at 10:40. Yes, everybody goes to school. Everybody's going into school for the tests. Keep asking questions. If you've got questions, ask them. I'm here to help. Fish. Any other questions? Okay. And these dates are on Teams. I posted them on Teams a week ago, maybe. So if you're not sure of them, if you didn't take a picture of them, they're on Teams. You can find them there as well. All right. Back to algebra. So like I said, today we're starting topic 10. We're here today. This is the 12th, starting topic 10. And today's lesson is going to be a little bit shorter, I think, but there will be homework at the end. So if we do finish early, that's a good chance, good opportunity for you to start your homework early. So let's go ahead and get started. So topic 10 is still quadratics. So we're continuing with quadratics. We're just going a little bit further in depth. And the first thing that I wanted to do is to just quickly do a little bit of a review of how to find x-intercepts if you're in factored form. Now, how do I know that this is factored form? Who can remind me what I'm going to look for? How can you tell when something's in factored form?
You'll see
parentheses. Good. What else? What is it missing?
the 2, the exponent 2.
No exponent. Good. So there are parentheses, but there's no exponent. So with that in mind, here's one example of factored form. And we want to find the solutions. Now, solutions is another word for what?
X-intercepts.
Good. So we're going to find the x-intercepts of this equation. Now, let's go right through it. Who can remind me? What do I do to each of these factors?
Flip them.
Not just flip them. We have to be very careful. Sometimes you can just flip them in your head, but we want to take it the long way just in case, because what do we notice? I have a 4 in the front.
So you have to bring 4t minus 12 equals 0.
Good. So I take each of my factors and I'm going to set them equal to 0. Now let's talk about why I do that. Why am I making them equal to 0? Can anyone explain that in their own words?
Because if we make them equal to 0, 0 means the y-intercept, because, for example, if you do 0 comma something, that would be y-intercept, and if you do x comma 0. That will be the x-intercept.
Good. You hit it right on the head. So basically an x-intercept, wherever it is, it's going to be x comma 0, right? It's on, that's why we call them zeros. It's on the x-axis, so it's a number comma 0. So x is the input value, and what do we call the 0?
Output.
The output. So here what I'm doing is I'm making the output 0. And when you make the output 0, when you make it equal to 0, you can solve for t and then figure out what is the input value. So basically what's going on here is I'm taking my factor, I'm forcing it to be equal to 0 in order to figure out what the x-intercept is going to be. So let's go through it and let's figure it out. I made it equal to 0. Now what can I do to both sides? I'm trying to get t all by itself. What should I do here to both sides?
Add 12.
Add 12.
Add 36.
And on the other side, I'm adding 36. Good. Okay. And now what can I do in both cases?
Divide.
Good. I can divide by 4. 12 divided by 4 gives me 3. And 36 divided by 4, I get 9. So t equals 3 and t equals 9. Those are my x-intercepts. Let me move this a little over here. Those are my x-intercepts. And what I can do is now I can sketch a graph of this function. So we're going to do that as well. Now, the reason that sketching is really, really helpful is because it helps us to visualize what this graph actually looks like. And right now, I know that the x-intercepts are at the 3 and the 9. So I can start to put those points down. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, do I know anything else other than the x-intercepts?
No. We could put it in standard form.
We could put it in standard form. What would that help us to see?
The y-intercept.
We could do that. And then what else? Is there anything at all though? Look carefully. Is there any other hint in this equation?
Yeah, the negative in the front.
Ooh, and what does that tell us?
It's another x.
It's not another x because there's no x there. If there's an x in the front, that's when you would have another intercept. But this is just a negative sign. So what does that tell us?
It's reflecting.
It's reflecting. It's flipped. And what that means is, what type of graph am I going to have? Am I going to have a smiley face or am I going to have a frowny face?
It'll face downward.
Face downward. Yeah. So let me just do a sketch. Now, this is not a perfect drawing, obviously. It's just a sketch, but it gives us a pretty good idea of what the graph might look like. And I heard Ijira saying we have a maximum. Good. So I don't know where this is. I don't know yet where that is, but I do know that it's a maximum because my graph faces downward.
We could try to guess where it is.
You can. Yeah, we know how to do it, but we're not going to do it right now because that's not the point of what we're learning today. So explain though, how would I figure this number out, Ijira? We're not going to do it right now, but how would you do it?
You could do it the long way by making the factored form to standard and the standard to vertex form, or you could get the 3x and the 9x and then you try to find the middle of them.
Yeah, where would be the middle between the 3 and the 9? Where is that? What number is right in between 3 and 9?
6.
6. So I know that this is 6 right here. That's a 6. So I know that the vertex is 6 comma something. Now I can take that 6, I can plug it in and then figure out the y value. But like I said, that's not really what we're focusing on today, so I don't want to spend too much time on that. Maybe if we have time at the end, we can come back to this problem and then figure it out. But for now, the most important thing I wanted to review was just how you find the x-intercepts. Do I have any questions on this part? How to find the x-intercepts?
No, I don't think so.
Okay. Now, if you do, now's your chance. Remember, we got less than 2 months till the EOC. Now is the time. Now is the time to start asking questions. Okay. So let's try another one. This is a word problem, but it's still going to be very similar. And can I get a volunteer to read it for us, please? Allison, go ahead.
The height of a football after it's been kicked from the top of a hill can be modeled by the equation h equals 2 negative 2 minus 4t, 2t minus 5, where h is the height of the football in feet and t is the time of seconds. How long is the football in the air?
All right. So it's asking how long was the football in the air? Now, what that means, let's picture what's happening here. They kicked it from the top of a hill. So actually, let me just draw it this way. Okay, here's my hill. We're up here. And we have a football and we kicked it. So it's going to look something like this, right? It's going to go up. We're on a hill, so it's going to go up and then it's going to come all the way down to the ground. Here's my equation. Let me rewrite it over here. And we're going to do the same exact thing that we did in this problem. We have 2 factors. We can take each of them out, set them equal to 0, and then solve. So I want you guys to take a moment to try that out on your own. Take these 2 factors, make each of them equal 0, and then let's see what we get. Take about 2 minutes.
We give you the answer in the chat, or
You can send me the answer in the chat, yes.
we could have a decimal at the end, right?
You can, yes. Especially because we're talking about seconds. So we know that seconds aren't always going to be whole numbers. Take about 15 more seconds. Send me your answers in the chat when you have them. All right, and 5, 4, 3, 2, and 1. Let's take a look. Starting with the one on the left, what can I do to both sides of this equation? Right here.
Turn the -2 to +2 by adding it to the right side.
We're going to add it to the right side. Okay. That leaves me with -4t equals 2. Now what can I do to both sides here?
Divide.
We're going to divide by what?
-4.
-4. And 2 divided by -4, what does that give me?
-0.5.
-0.5. Okay. All right, now I have the same situation over here. I have to do a couple things. I want to hear from students that I don't typically hear from, especially those who I've been reading on the side while I waited. I was reading your responses and I see some responses at the end where I ask, what are you going to do to bring your scores up? I see someone's participate more in class, even when I'm unsure of the answer. Stay off the phone. Yeah, you should be doing that anyway. Let's see. Yep, somebody else said going to ask more questions, study more, focus more. Okay, so those of you who are telling me that you're going to be asking more questions or participating more in class, now's the time. Let me hear it. What am I going to do over here first? Move the -5. Good. So I can do what to both sides? If I want to move that -5, I'm going to add. Good. All right, I'm left with 2t equals 5. Now what? How do I get this t all by itself? Good, I'm seeing it in the chat. It's okay if you want to say it public or private, whatever. But either way, I'm seeing it. We're going to divide by 2. Why am I dividing? Why am I dividing rather than subtracting, for example? Okay, so you can have the t alone. Because remember, the 2 and the t, they're being held together by multiplication. That's 2 times t. Well, the opposite of multiplication is division. So that's why we divide. And what's 5 divided by 2? Good, 2.5. All right, there's my 2 x-intercepts. Now let's quickly sketch this graph. Let me do it correctly. Because I have a negative and I have a positive. And that's going to mean that we have to do something interesting. Because let's see. Okay, 1, 2, 3, -1. I have -0.5 right here. And I have positive 2.5 right here. Well, this is a real world situation. So what's the problem? If this is real world, what's the issue? Yeah, Lauren's got it. The negative. What's wrong with this negative right here? What do we say when it's weird? Well, this is measuring, what does the x-axis measure? It measures time. So why is this bad? Okay, good, Raymond. You can't have negative time. Can anyone remind me what it's called when you get an answer, but it doesn't work in the real world?
Not viable.
Not viable. Good. Not viable. That's the key. That's the vocabulary word. Okay. So if you see that on a test, now you know what it means. It means that even though it's the right answer, it just doesn't work in the real world. So all of this part of the graph is not viable until you get over here. This half is totally fine. So all of this is good, totally works. It's just that this part over here does not work. So there's our graph. How long, here's it, now we got to answer the question, how long is the football in the air? Can anyone tell me? But how long means time. How much, for how long, for how many seconds? Look at the graph. Look at the graph to figure it out. Look at the x-axis. Here's our starting point. Here's where I'm kicking it. I kick the ball. It goes up. It comes back down. How long is it in the air for? There you go, Allison. 2.5 seconds. 2.5 seconds. Right here is where it ends. That's the 2.5. So I know that if I'm starting at 0, it's in the air for 2.5 seconds. Any questions on that? All right. You don't get it, Guillermo. Okay. This is 2.5 right here. Right? This is the 0 right here. This is where you kick it. You kick it. I start the timer at 0. It goes up. It comes down. Boom. 2.5 seconds. This is where we end. So from the 0 to the ending point is 2.5 seconds. We're not talking about the height. We're not talking about how high up it goes. We're talking about how long it's in the air. Someone saying, but doesn't it end at 2.5? Yes, but okay, if you have a timer on your phone, right? And you're gonna press the timer at 0, and then you press the timer again when it ends, right? We go start, stop. The time that you press stop, that's how long it was in the air for. So even though this is where it hits the ground, that's also measuring how long it was in the air. Does that make sense? Did I explain that okay? I can try a different way. So I guess technically it was in the air for a tiny bit right before 2.5, but we can round up and say that it's 2.5. All right, any other questions? If it's being laggy, you can try leaving and coming back, or you can just be patient and see if it loads a little later. Is it lagging for everybody or just those of you who are at school?
You're good for me.
Okay, it might be the school Wi-Fi then. All right, so this was factored form. We've been talking about factored form. Now what we're moving on to, and by the way, this was all review. We were reviewing how to do this. Now, new stuff. What happens if I ask you to tell me the x-intercepts, but then it's in vertex form? Does vertex form tell you the x-intercepts? No. What does vertex form actually tell you again?
Vertex.
The vertex. So the vertex tells you the vertex. In this example, where is the vertex?
-2, comma -25.
Good. -2, comma, -25. Why did Ijira tell me it's a -2? I see a +2 over here. Why did she say it's negative? Can anyone explain that? All right, so, oh, I'm glad. Okay, so if anyone else is having issues, you can try leaving and coming back. It worked for Guillermo, hopefully it works for everyone else. So as I was saying, this is negative because you always have to flip the sign of that number. But in any case, this is my vertex. Exactly, Karina. Since it's positive over here, when you actually give me the vertex, it's negative. Well, okay, vertex form tells you the vertex. That's awesome. But today we're going to figure out how to also find the x-intercepts. So we're going to find the zeros, find the solutions of this equation using a strategy that you might have we've done very similar things in the past. And so what we're going to do is solve this equation. Now here's my stickies. I'm going to write all the steps on this sticky note. That way we have them with us. Okay, let me move this up a little bit. Cool, here's the note, perfect. All right, so here's my quadratic function. It's a function because it has h of x. But what I'm going to do is I'm going to turn it into an equation instead. And the way I'm going to do that is I'm just going to set the function equal to 0. Now remember, we did this before. We did this over here. We made it equal to 0. But the only difference is that this time I'm actually going to make the whole thing equal to 0. So watch. All I'm going to do is I'm just going to replace this with a 0, and everything else stays the same.
So this is vertex to factored.
This is vertex to, it's not going to turn it into factored form, but it is going to tell me the x-intercepts at the end. Okay. All right, so now that I have it equal to 0, we're going to solve for x. I want to find the value of x. Well, in order to do that, I'm going to be treating this like a normal equation. And then you'll see at the end, there's going to be one extra step. But if this is just kind of like a normal equation, what does your gut tell you to do first?
Foil.
Okay, your gut tells you to FOIL, right? Because you have this exponent, but we're not going to FOIL because foiling will only make the equation even harder to solve. Think about what our goal is right now. We're trying to get x alone, trying to get it completely alone. So
divide x by everything?
Okay, so remember division would be the opposite of multiplication. Is there multiplication involved?
For the exponent, yes.
Mm-hmm. What other operations do we see here?
Oh, distribution.
There's exponents, good. What else do we see? What other operations? There's an exponent. You guys keep saying distribute, and that's because I see parentheses as well. So parentheses, exponent, what else? Addition, right here. Addition, we're adding 2, and there's one more thing.
Subtraction.
Subtraction, right? We have 4 different things going on. We have exponents, we have parentheses, we have addition, and we have subtraction. And what we basically need to do is to undo all of those operations. Because remember what solving means. When you solve an equation, you have to undo everything. You have to use your inverse operations. So looking at everything we need to undo this subtraction, we need to undo this addition, we need to undo the parentheses, and we need to undo the exponent. Which one of those things should I try to get rid of first?
Do we follow PEMDAS?
Kind of. Think about PEMDAS a little bit.
So we get rid of the exponent by distributing it?
We'll get rid of it a different way, but we're not going to get rid of it first. There's something else that has to move first.
The negative 25?
That's it. That's the one we're moving first. And let me explain why. You mentioned PEMDAS, right? What we're basically going to do is we're going to do PEMDAS, but we're going to do it backwards because we're not trying to simplify this equation. We're trying to solve this equation. And in order to do that, we're going to have to get rid of everything until we're left with the x all by itself. So if we're following PEMDAS backwards, subtraction and addition come first. So we're going to undo this 25. Now, what operation should I use to bring this 25 to the other side?
Addition?
We're going to add. Exactly. We're going to add 25 to both sides. Well, now I have 0 plus 25. That gives me 25. So what did we just do? This was step 2. This 25 is the k value. It's the k value. And that's exactly what we moved. We moved the k value to the opposite side. Now it's here. So we did subtraction, and we can also cross off addition because we already did. It's always one or the other. Now, the next thing is to multiply or divide. Well, usually there's a coefficient. In this case, what's my coefficient? What's my a value?
1.
It's a 1. Do I really need to divide by 1? Okay. So we can essentially skip that step, but we'll see it in the next slide. So we can skip number 3. Okay. Now here we are. Now exponent comes next. Now we want to go ahead and get rid of that exponent. But let's think about this. We always want to use inverse operations. So I want everyone to answer me either out loud or in the chat. These are going to be easy questions. You ready? What is the opposite of addition?
Subtraction.
Okay. What's the opposite of multiplication?
Division.
Addition.
Okay. Now here's where it gets a little harder. What's the opposite of going to the power of 2?
Adding 2?
Not going to be negative 2. Think
Would it be regular 2?
It has something to do with the number 2. It has something to do with the number 2. Remember, this is x plus 2 squared. And Raymond's on the right track because the power of 2 tells you to multiply something times itself. So it's kind of like division. What was that, RL?
I said so divide it by itself.
Kind of. And there's actually something that we can do that we already know how to do. So again, think about this. This is x plus 2 squared. Squared. What's another operation that involves the word square?
Root. Square.
Oh, square root. Yeah. The opposite of this exponent of 2 is to take the square root. Think about it. Let me give you a quick example. What is 8 to the power of 2?
4.
No, 8 to the power of 2.
8 to the power of 2, 64.
64. And what's 64, the square root of 64?
6. Wait, wait.
What's the square root of 64?
8.
8. So notice, 8 to the power of 2 is 64. Well, the square root of 64 is 8. So that's how you can tell that this is the opposite operation, because those two numbers, those are related to each other. In one direction, it's because you took the power of 2. Now, the opposite of that is to take the square root. So what we can do now is we're going to take the square root. So that's step 4. But if I'm taking the square root of the right side, what else do I have to do? If I go and I'm going to take the square root over here, where else do I have to take the square root?
25.
Yeah. So we take the square root of both sides. Both sides. Okay, what is the square root of 25?
5.
5, right? So the square root of 25 equals 5. And then what happens here is you can eliminate the exponent. So I'm left with x plus 2 all by itself. However, I'm going to ask this again. We said the square root of 25 is 5. But what if I told you that there's also another answer? What's another square root of 25?
3 by the power of 3.
Nope, 3 to the power of 3 is 27. I'm taking the square root. So we know that 5 times 5 equals 25, but there's another number that when you multiply it times itself is going to give you 25. Five times 5 is 25, but what other number times itself gives you 25? Three times 3 is 9, not 25. Keep trying. What number times itself gives me 25? 1 times 1 is 1, Guillermo. That is not 25. 25 times 25 is 225, I think. Five times 5 is 25. I want y'all to think outside the box. Positive 5 times positive 5 gives me 25.
Negative.
Negative 5 times negative 5 also gives me 25. Why is that? A negative times a negative is a positive. So what you have to do is you're going to split this up. You get your positive 5, but you also get negative 5 equals x plus 2. So let me write our final step. So we just took the square root of both sides. So now we're going to, how do I phrase this? We're going to use the positive and negative answer to solve for x. Because now I have these two mini equations. They're pretty easy and short. And we're going to solve each of them, and then we'll be done. So on this equation right here, what can I do to both sides to finally get x?
Bathroom.
Yes, go ahead. What can I do to both sides over here to get x by itself?
You add 2.
Careful, we already have plus 2.
subtract 2.
Subtract 2. What's 5 minus 2?
3.
So I get 3 equals x, or x equals 3. And then over here, what do I do to both sides there?
Subtract.
Also subtract. Now what's negative 5 minus 2?
-7.
Negative 7 equals x, or x equals -7. And there are my two solutions. There are my two x-intercepts. So those are my steps. Let's review what we did. The first thing was we set the function equal to 0. So I just make it equal 0. Next, I had to move the k value to the opposite side. So here I added 25 to both sides. Then we had to divide by the a value, but the a value was just 1, so we didn't really need to do that step. Number 4, take the square root of both sides. The square root of 25 is +5, but also -5. So you have to use the positive and negative answer to solve for x.
Oh, but like, would there be an answer or like an expression? No, is this an expression or an equation?
This is an equation that we just solved.
Oh, okay. So if there is like an x
Mhm.
of the, not in front of the equation, but in front of the parentheses,
Like here.
Yeah. Will there be a different like process than this?
Yes, there would, and we're not going to do that at all. You're not going to see that in this year, because that wouldn't be a quadratic equation anymore. That would be a cubic equation, which we're not going to cover. All right, so now that we have all this information, I'm going to just copy this sticky note and delete it because I need room. Now we have a lot of stuff. We can sketch the graph of the function because we have the vertex. We started with the vertex. Now I have my x-intercepts. And basically with all that, I can easily graph this function. So, oops, that was backwards. It's over here. Okay. So I know that I have my x-intercepts at -7. And +3. And my vertex is at -2, -25. So I'm just going to say that that's 25. Because again, this is just a sketch. But here's -2, -25. And my graph is going to look something like this. So because of this strategy that we used, it's really, really easy at the end, after you're done, to know exactly what your graph is going to look like. Because once you have the vertex and the x-intercepts, that's basically all the information you need. Now, we don't know the y-intercept, but we can also figure that out. But that's not what we're focusing on right now. That's a big boy. Yes, Guillermo, it is. So I know we've only done one example. We're going to do a few more, but does anyone have any questions at this point that I can answer? Okay, let's do another one. The best way to understand how to do these is just to keep doing it. So here we are. First things first, what is my vertex again? In this case, let's just get that down from the beginning. What's my vertex?
+3.
3, 4, yeah, +3, 4. Okay, now we're going to follow all the same steps to solve our equation. So first things first, I'm going to set it equal to 0 and just copy everything else down. Then I need to move my k value to the opposite side. So what should I do on both sides? Good, Guillermo, -4. What's 0 minus 4? Yeah, -4. Cool. So I did step 1, I did step 2. Step 3, divide by the a value. What is my a value in this case?
-1.
-1. Remember that this negative sign is really a -1. So now I do have to do step 3. I'm going to divide on both sides by -1. Well, what's -4 divided by -1?
Wait. Oh.
Juan's got it.
Did we skip the third one, the third rule, or?
No, we're doing it right now. We're dividing by the a value.
That's why I got confused.
And Juan's got it. It is +4 because negative divided by a negative gives me positive. Okay, now I have to take the square root of both sides. And what are the 2 square roots of +4?
2.
+2 and
-2.
-2. So remember that you always need to do the positive and the negative. Now let me move this up a little bit so I have more room. So I have, wait, that's not what I meant. Okay. So I have +2 equals x minus 3, right? Because this cancels out. And then I also have -2 equals x minus 3. And then finally, I'm going to use the positive and negative to solve for x. So to solve for x, I'm just going to do one last little step. What should I do to both sides over here? Add 3. 2 plus 3 gives me
5.
Gives me 5. So I get x equals 5. Same thing here. I'm going to add 3 to both sides. What's -2 plus 3?
1.
+1. So +5 and +1. Now over here, because I saw a little bit of a commotion in the chat, so let me explain. The square root of 4, when you take the square root of something, it's kind of like dividing. So I saw in the chat, somebody gave me 16, that would be 4 to the power of 2. But we're taking the square root of 4, so it's the opposite. So you end up with the smaller number. That's okay, that's why we're here, we're learning. All right, we got all of our information. Does anyone have questions? Take a moment, look through the steps we took. Now with all that information, I can graph this function, or I can do a sketch. All right. So I know that my x-intercepts are at +1 and +5. When I draw my sketches, I basically just look at the numbers, and I know that they're going to be all pretty small values. So when I make my graph, I don't need to make it really, really long because I know that it's going to be within these numbers. So Guillermo, +1, not -1. There you go. So +1, you can go for it and put another one at +5. And if anyone wants to put the vertex, do it in purple. Go for it. Do my work for me. I don't mind. Good, RL. 3, 4. All right, and now I have everything I need. Now I can connect these dots. We're gonna go up and then come back down. Okay. So how do we feel? Any questions on this one? The more we're gonna do about 2 more examples. So the more we do, and the more sense it'll make if you're still a little bit stuck. What is happening in here? I'm gonna take that to mean that we don't have any questions. Okay. Next up. Oh, let me clear the screen. All right. Here we go. Same steps, but now that we're kind of getting the hang of it, I want you guys to tell me in each step what I'm gonna do. So I'll start it off by setting it equal to 0. Now what?
We should all have a return to end.
Yeah, type it in the chat. Everyone type it into the chat. I want to see as much participation as possible. You can do it on private, you can do it on public, but I want to see all the answers. What do I do first? Okay, I already did that. What was that?
Find the vertex.
Find the vertex. Where is the vertex? I see Guillermo already put it. Guillermo, check again. You're close. You were closer before. There you go. 6, -8. -8. So remember, this number is exactly the same. You don't change that one. The only one that you flip is this one. Okay. All right. Ijara gave me the next step. So now I need to solve this equation. So she's putting the 8 to the other side. And she did that by adding it. So I'm adding 8 to both sides. I got 8 equals 2. Who's calling me? Oh, okay. 2 times x minus 6 squared. Now what? Okay, that's my exponent. Is it time to take the square root yet? Oh. Careful, yeah, you almost skipped this step. We have to divide by the a value. So we're dividing by 2 on both sides. Oh, you can keep it there. Or I'll write it again. Oh, there you go. Okay. So we divide by 2 on both sides. 8 divided by 2, I get 4. Cool. Now we can do step 4. Now we can take the square root of both sides. So this exponent, I want to get rid of it. We take the square root of both sides. What's the square root of 4?
Two.
And?
-2.
Good. Positive 2 equals x minus 6. And -2 equals x minus 6. All right, from there, last step. Who can tell me what do I end up getting for my 2x intercepts?
We add 6 on the left side.
We add 6. So I get x equals
8.
8. Now on the other side, all this conversation coming from students who I know for a fact need to bring their grades up.
X equals 4.
4. All right. X equals 8 and X equals 4. Now let me just fix over here. Cool. Any questions? We went through this whole, we're almost at the slide where you guys are gonna have to try it on your own. So any questions now while you still can?
I have a question for the quiz.
For the quiz?
Yeah, even though it's like like a week or so.
Yeah. Uh-huh.
Are we going to graph stuff on the quiz, or we're just gonna do this as we're doing now?
Mostly just this, mostly just solving. I think there might be maybe 1 or 2 questions with graphs, but you're not going to graph it yourself. You just have to pick the right graph, multiple choice. Okay, someone's asking me a question. Inside the parentheses, why didn't it become positive? Okay, so there's this really common misconception. This minus sign is still a minus sign. I'm not magically changing it in any way. The only time where I change it is when I'm telling you where the vertex is located. So the only time that you ever mess with this is when you're telling me the vertex. Other than that, we're just gonna keep copying it down exactly like we see it, because it's not that I'm changing it from a negative to a positive. It's that, and this is where it gets a little confusing. It's hard to understand, but the vertex kind of has like a special property, if you can think of it that way. So for that reason, it's going to be flipping. But here, I'm just solving. So I'm not going to magically transform that into a plus sign. I'm going to keep it as a minus sign all the way through, okay, until the end. So that's something that students sometimes kind of get confused about. But if you can just remember, the vertex is where you flip it, but any other time, you just keep it. All right, now we graph. I'm going to put up my graph and I want you guys to graph it for me. I'm tired of doing this. Just kidding. Okay, here we are. So let me add a few. All right, go for it. Good, I see my x-intercepts. Careful with that. What's that? That's 8,6. Wrong place. There we go.
Around this area.
It's +6, -8. So whoever put it down, you got it.
Oh, haha.
And try to drag that all the way down. Try to make it nice and even. That's a little better. And don't forget though, I know that you made a nice smiley face, but don't forget that it keeps going. So keep bringing this up all the way up and make your arrows. No, oh my God. Make your arrows. Oh gosh. Okay, good. There you go. There we go. That's a little better. Smiley boy. Good job. Okay.
Relaxed too many smiles.
Yeah. Okay, this is getting crazy. Oh my God. It's kind of creepy, actually. I don't like that.
Why does it
Okay.
look like Humpty Dumpty?
All right, this is the only chance you're getting to make your beautiful creations. But do I have any questions? Oh, Jesus. Okay, that's it.
Okay, that's it.
That's where we draw the line. Okay. All right. I'm just going to draw it one more time just so we have it in case anyone's taking screenshots here. 1, 2, 3, 4. There we go. And there we go. Cool. Any questions? We're doing one more. Here we go. This is your turn now. So I'm going to paste the instructions again, but this is something that as you practice it, you should memorize. And by the way, your homework is going to look very similar to this problem. So right now is a good chance to make sure that you know how to do it now. That way, when you do your homework, you don't get lost. So if you are able to do this question, you should do very well on your homework. So go ahead, get started.
Can we just
There we
type in
go.
the final answer instead of the process?
Yes, but in this example, I expect there to be at least 1 or 2 questions in the chat because there's something a little bit different. I'm not going to give it away, but there is something slightly different about this problem than the ones we've been doing.
Oh. Okay, I see where you. Okay.
I'm gonna wait till I see like at least 3 people with the same question, and then I'll go over it. So I want you guys to notice what happens. So I see 1 person who notices the issue. Does anyone else notice the issue in this case? Let's take a couple minutes. Okay, if I can get 3 people to tell me what the issue is, then we can continue. But right now I still only have 1 person. So what is the problem in this problem? The negative? No, negatives are not a problem. Go back to question number 2 we did. This one had a negative sign and that was totally a-okay. We still did it. So it's not the negative. Negatives are fine. Keep looking. Go step by step. Try to solve it step by step and tell me when you hit a problem. Not the G. The X is not a problem. We're just trying to solve for X. Y'all are just looking and trying to find issues. You're not solving. You need to try and solve it in order to find the issue. You're not going to find it unless you try. We're running out of time. You might end class without knowing the answer to this question. Someone saying the exponent is a problem. They're getting a little closer. It has to do with the exponent. I think Bianca's got it. So right now I have 2 students. I'm waiting on 1 more. Who else can figure out the problem? I'm not going to give you the answer. That's too easy. Y'all have to figure it out. And if you're still trying to figure it out, that just tells me that you haven't actually done anything. You'll find it. Once you start this process, you'll find it. Those of you just throwing out random answers, you haven't actually done the process. Okay, Guillermo's out here trying to solve it. David, I think you're close. Can you be more specific? What's wrong with that? You're close. A lot of students I haven't heard from. Sophie, RL, Christopher, Karina, Jade,
Miss Lopez,
Han.
just give them the answer because the bell's about to ring.
I'm not giving y'all the answer.
That's
Even if
literally
if the bell rings, that's on you.
Well, can you at
What
least
is it? What is the answer?
I'm not
I
giving
don't
it
know what
away.
it is.
can you
I'm not
explain to the people who knows the answer in the chat how to do the rest of it?
Now you'll have to wait till tomorrow to find out.
is it the 5 or something?
But if you want to try
Give me
Is
a
it
this,
the
clue.
exponent?
what?
Is it the exponent?
Well, the
Oh.
exponent is not a problem, but it does kind of have to do with the exponent.
Miss Lopez, give me a
Allison-
clue. Dame un
Allison
clue.
and RL, if you piece their 2 clues together, you'll get the answer. It has to do with the 5 and the exponent.
They're saying it's an equation. Where's look up the equation?
That's confusing.
Did you try to solve it, RL? Did you go through each step? You're not going to get it unless you start solving and going through the steps, just like I did in this problem and this problem. If you don't go through this process, you're not going to find the problem. You have to do it yourself. That's why I'm not giving it away, because I can tell y'all are not doing the problem. 5 squared. Really close. Nope. Y'all got 3 minutes left. You're cheating. Okay, go for it. Cheat away. See how much that helps you in the end. All right, Ijara, give it away. What's the problem?
Yay! The problem is 5. Cinco.
What's wrong with the
I
5?
literally said that.
No, but you got to be more specific. What's specifically wrong with the 5?
When you
I-
go to step 4 and you have to do the square root of 5, there is no square root of 5.
What's the square root of 5?
2 point something 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 something.
25.
Okay, real quick. I know the bell's about to
Fine
ring.
tune, break, take yourself.
I literally said you have to subtract the square root of 5, bruh.
No,
You
you
got
didn't.
scammed.
No, that's not what you said. That's not what you said. Don't make up some lies out here. Okay, so I'm on step 3 now. I'm dividing by -1 on both sides. Step 4, so I get 5 equals x plus 2 squared. Step 4 means I have to take the square root of 5. What's the square root of 5?
5,
No. What's the square root of 5?
15,
No.
25,
No.
negative 25.
Do you get a whole number or do you get an irrational number?
Irrational. 2.23, 60, 67, 97.
You get an irrational number. So tomorrow you'll learn what to do when this happens. But tonight you can start on the homework, see how much you can do. You'll be able to do a few questions without any issues. So I suggest that you start on it just to get some practice. Tomorrow we'll continue with this. I will see you all then. Sorry for the torture, but sometimes you got to do it.
Chicken wing, chicken wing,
Bye, everybody.
chicken wing, chicken macaroni.
Have a nice day, Ms.
Have a
Lopez.
nice
Hot
day,
dog.
everyone. Bye.